Welcome to the Agentic AI for Enterprise video course 2A. In this course, we'll be covering the key components of Agentic AI for Enterprise. The key components of Agentic AI for Enterprise are training of the LLMs. The AI model is designed to process and generate the human understandable language. So LLM, as you know, is the AI model, which is a large language model designed to process and generate human understandable, uh, human understandable language. The prompt engineering is another key component which helps in creating effective inputs for the LLM. Retrieval augmented generation, as you know, RAG enhances LLM generation capability by providing accurate and relevant and up-to-date information. So another most important part of the agentic AI is the APIs. APIs are designed to integrate the cross-platform agents to integrate agents with the software or with other apps or websites. APIs are required to basically provide role-based security for the policy governance as well as to manage scalable agentic workflows. Dynamic tools discovery and plug and play integration of tools is also possible using the APIs. So we'll be covering key components in 4 sub-presentations, which are labeled as 2A, 2B, 2C, and 2D. So now we are starting with the 2A, which is training of the LLMs. So as you know, the core capability of LLM, which is a subset of deep learning, and it's called large because it uses billions and trillions of parameters. Core capability of LLM is it can predict the next word in a sequence, which is called language modeling. So it learns the grammar, the syntax, semantics, and factual knowledge, and common sense reasoning in a sentence. And it also learns the writing styles. So when we trained LLM, what really we trained the model is that we create a capability in the model to predict the next word, which might be missing in a sentence. So that model has a learning capability to be able to produce that mask word. And deep learning and neural networks basically are LLMs are using deep neural networks, specifically the transformer architecture, to do the functions which they are designed to do. That is to generate the text, code, and summaries and answers. So, as I mentioned, transformer architecture, what is it? It is effectively the handling of sequential data like text. So it uses a self-attention mechanism which weighs the importance of different words in a sentence and then it makes prediction. Suppose in a sentence, uh, so it talks about, say, a kettle is moving, and the next part of the sentence say it's uh, it's having grass, it's eating grass. So it recognizes the meaning of it is about the kettle. So the self-attention mechanism helps us to achieve its objective. It creates the context and it creates the relationship of various words in the text. The feed-forward network, which is a neural network process, it creates each word's representation independently in the form of tokens, which further refine the model's understanding. It's highly effective and its sequential data like text, it helps to do a parallel processing. So it's quite effective and efficient. The training objective in a LLM architecture using transformer would be that it has to predict the next token. It predicts the original mass word in a sentence, which is based on the surrounding context. So LLM training can be in two phases. One is called pre-training, which is more a unsupervised learning. And second part is fine-tuning of the training data. Fine-tuning is done by supervised fine-tuning, or there's another technique which is reinforcement learning from human feedback, which is called RLHF. So RLHF technique prevents undesirable results from being predicted by the AI model. So human feedback means human monitors what are results are being created by the AI model. There is a human feedback loop is there, and human feedback provides a grade to the kind of output created by the model. And if that grade is higher, that model is more reliable. And when we talk about model fine tuning, we'll discuss more about how we fine tune a model. So LLM pre-training, what we really do is we do the data collection at stage 1, where we train vast amount of data from books, code, websites. Here the quality as well as quantity of data which we collect is very important. So pre-processing steps are tokenization. That means the raw text is broken into smaller units. A token can be a word or part of a word, or it could be even a punctuation mark, so that when we make a sentence, it's made of several tokens. So cleaning and formatting is another part of the pre-processing, where irrelevant content, the HTML tags, special characters, errors in the data quality are removed before data is taken for training of the model. So as we have seen, predicting the next token from a sequence, self-supervised, is the one which is done in the pre-training. Now for pre-training itself, lots of GPU and TPU power is used and distributed systems are required. There are several physical users are there who are training these LLM systems. Fine-tuning and instruction alignment. Instruction tuning means prompts, ideal outputs which are being created from the prompts. So human in the loop decides whether if somebody is doing a prompt, the result of that prompt meets the expectation. And then reinforced learning, the model uses proximal policy optimization. It has policies, it already has tokens, and it has policies through which the proximal tokens, they arrange the tokens in such a way that whenever there is a need to fetch a sentence, the model picks up the tokens which are nearest to each other. So there is a technique called loss function technique, where low rank optimization or quantified low rank adaptation, a mathematical function that quantifies the error of the model's prediction. The loss function compares the model's predicted word or token with the actual correct word. So greater is the difference, higher is the loss. So goal of training is to minimize the loss. That means the text which is generated by the model should be nearest to the expected text. If the loss function is high, it means there is a correction required. So there is another technique which is called optimization. There is an algorithm called ADAM, which uses the calculated loss to adjust the model's internal parameters like weights and biases. So it works by iterative updating the weights in the direction that will decrease the loss. So effectively it teaches the model to make better predictions. So basically using these optimization techniques and using reinforced learning, using human in the loop and human feedback, we are able to fine-tune these models. So efficient fine-tuning means where we fine-tune a model, but we also efficiently use the resources. So that is possible when we are training LLM on a highly specialized data set. That is like a medical or a legal data set. These are specialized data set which make it expert in those specific domains. So there are techniques like parameter efficient fine-tuning, which aims to reduce the computation cost as well as memory for domain-specific fine-tuning. So again, techniques are same, reinforced learning, there's a prompt-based tuning, there's a LoRa, Q-LoRa techniques, and we have the PPOs, where we optimize the proximity-based tokens. So in a sense, LLM training moves from a broad, unsupervised understanding of the languages to a more refined and instruction-following and human-aligned capability. And that is made possible through the multi-stage training processes. As we discussed in this video, training processes involve the retraining and fine-tuning. So major AI companies like OpenAI, Anthropic, Meta, they are investing heavily in the RL environments, which is reinforcement learning environments. There is another model which has created a lot of buzz, that is Chinese DeepSeek AI innovation, which is using R1 reasoning model, which has been developed by China using reinforcement learning through group relative policy optimization, where they define the policies of the groups of data. So it teaches reasoning without human created examples. So it allows the R1 to develop its own problem solving capabilities. One of the advantages of this is it's able to train the models at a fraction of the cost which US companies have been incurring. So there are pros and cons of such an approach. Humanoid robotics and AGI. So that is the next phase where OpenAI views embodied artificial intelligence as essential for achieving the artificial generated intelligence, that is AGI. So AGI is the next phase of artificial agentic AI, where it is adaptive artificial general intelligence. The model learns on its own, and the model is embodied in humanoids, like humanoids working in the factories and replacing human beings. Elon Musk, as per reports, claims 80% of Tesla's future value will come from the Optimus robots which are being developed by Tesla rather than the electric vehicles. They expect 80% of future Tesla revenue would come from these robotics. So with this, we'll move on to the next chapter, which is 2B, which covers the prompt engineering. Thank you so much.